Morning. Thank you guys for being here. All right. 2 minutes. We got it. Oh, no worries. But yes, please.
This ballpark thing, what's the timing?
I mean, you don't have to do all three subjects tomorrow if you just wanted to do one. That's actually probably better as far as brain wise and what, but if you wanted, yeah. But if you, of course, if this is kind of the only time you have. So language takes like 45 minutes max, math takes about an hour, and then reading can kind of take about 90 minutes.
Well, 2 hours.
So, yeah, yeah,
All right.
yeah. So
Just because that joke.
yeah, no, and yeah, we appreciate you coming in and making the time. And yeah, like Kayla is gonna finish her progress test up on Monday. Like Anita broke it up across 3 or 4 periods. So
I need to come in next week. I'm having issues with my feet, so it's hard to get out.
no worries, no worries. You don't have like cyborg feet yet?
No, not
Bionic?
yet.
I know. I'm hoping by the time we get really decrepit.
Yeah.
But that's a bummer. No worries. We're glad you could hop on Zoom. All right, I need to answer security questions. Ah. Um, and for you guys who are local, if a Flagstaff City bus pass would be helpful to you, I think there's still some available, so you can send me a message if that would be a useful resource, um, transportation wise. But of course, still a little bit of a trek from the bus stop, but actually the bus stops get you pretty close to this school. Same with the other CCC, but
I
it's a
get
little
one through the I get one through the county now. It's good
oh,
for like
nice,
a while.
nice. Good morning, Diane. Um, oh the oh really. I don't know why the audio feels really. All right. So sorry guys. So on Canvas, um, and I'm sorry about the announcement I sent out this morning. For something that's next month. There's supposed to be something going on while we're in class here too. Um, I answered a random ringing phone and they were like, "When is this thing?" And I'm like, "Oh God, what have I done?" But yes, you're correct, Nayeli. So yeah, let me remind everyone. So just to remind everyone, this is on the front page of our Canvas page here. And so yeah, we will not meet for classes next Wednesday or Thursday. Okay. So plan to do classes on next Monday and Tuesday, but then pretty much me and all of my coworkers, we get to go do some learning of our own down in Scottsdale. So we'll be gone from Wednesday through Saturday, going to a conference down there. So we won't have classes. Kelly will still be in on Thursday afternoon at her time from 3:30 to 5:30. She'll also be here today at that time if you guys have anything you need to work on. But yes, so thank you for reminding me. So yeah, no class next Wednesday or Thursday, and of course I won't be available next Friday either. Which is usually when if you needed to meet with me one-on-one or do other things. And so also remember that next Wednesday, Thursday, and Friday we'll have kind of limited availability. I probably will check my email, and of course Remind is the most efficient way to get a hold of me. If something comes up or if you need something, but of course I won't be around. I might not be as responsive as I can be in other contexts. So anyway, hopefully that's clear. Plan to do classes as normal next Monday and Tuesday. I will give you guys some independent work that I would strongly ask you to do while, class is canceled, because I really want to keep the momentum going, and and so if you complete, the independent assignments, I can also give you hours so that you're not losing, up to 3 hours of attendance because, I get pulled away to learn myself. But of course, hopefully it makes you feel good that the people who are working with you are also still learning. That always makes me feel good. Oh, and I wanted to let Kenneth and Adriano, I'm not sure when today, but I know that the CCC college president, Dr. Heiser, is going to be there to meet with staff and teachers and students. So if you guys are around and see like pop up with the prez, he has like a little banner. You should go in and say hi and let him know that. Well, we do have someone we might be interviewing to teach with you guys up there. So that's exciting. But it'd be better if you could advocate to him for what you guys need. And so Kenneth, if you have time today, see if you can figure out when that is. Okay, sorry, enough chitter. Okay. So a new compact car gets 48 miles to the gallon during highway driving. And 32 miles to the gallon. Oops, 32 miles. Ryan, you didn't point out my typo. So what is the ratio of the car's city gas mileage to highway mileage? And apparently I can't spell either, but like I said, sorry I threw this together so haphazardly. So we need city, which is 32, to highway 48. And then we just want to reduce that to lowest terms. So does anyone know the common factor, the greatest common factor between 32 and 48?
8.
16 actually, but 8 would work, Anthony, and you would hopefully recognize you might need one more, but yes. So 16 is the greatest common factor, but 8 would be the next greatest. 2 would work, 4 would work as well. Like it's all connected. Okay, well, let's do 16. So 32 divided by 16 is 2, and 48 divided by 16 is 3. So if we represent a ratio with a colon, right, for every 2 gallons of gas, right, that you use in the city, it would be 3 gallons of gas if you were driving on the highway. Okay, so I'm sorry that the answer was incorrect for everyone there. I apologize. So if you got that answer, you were correct. And I think most people did answer correctly. And I just am learning to. No, my silly scribbles. So yeah. So remember, order matters. So those folks who answered 3 to 2, right? That's highway to city, not city to highway. Order matters. Okay. And then here, right? Some people didn't reduce. Okay. Here, we're not calculating a rate, right? We're calculating a ratio. And we're looking at the relationship between city gas mileage to highway gas mileage, which is something pretty common, right? That you might be good to inquire about. Does everyone feel okay about the first problem? Awesome. Okay. Among every 60 people who order burgers at Chuck's Place, 30 order single burgers, 12 order double burgers, and 18 order cheeseburgers. What is the ratio of single burger to cheeseburger sales at Chuck's Place?
5 to 3.
5 to 3? How'd you get 5 to 3?
5 to 3. I could fit 5, or I could fit 3 into both each one.
Okay, good. So once again, if we follow our two rules of ratios, order matters, so we're doing single to cheese. So that's another thing that you'll see here, right? Is there's a lot of kind of noise, right? There's a lot of extra information that we don't have to use in the problem, and that is definitely a GED tactic. And so 30 singles, 18 cheeses. Ugh, plain hamburger. Haven't had a cheeseless burger. I'm like, when I didn't even know. All right, sorry, focus. So 30 to 18 is our kind of our big ratio. Okay. And then we look and say, can we reduce this? Yes, we can. I can divide a 6 out of those, Anthony, but I think you still got the right answer. And remember, when you set up your ratio before you reduce it, right? I'm like, okay, so the first number is going to be larger. So right away, right, I could eliminate answers, right, where it's like the smaller numbers on the wrong side. And so if that helps you, you know, kind of weed things down, that's good too. But yes, if I divide a 6 out of here, our greatest common factor, it reduces from 30 to 18, which is actually a 5 to 3 ratio. Okay. Everyone feel all right with number 2? Yep, Kayla, yeah. So that's why I put those 2 rules at the top of the page, but you might have missed me preaching those. Robert's not on Zoom to defend himself from your snark, Ryan, so it says, I bet Robert got it wrong. It's only fair talk smack if the person can smack back. Cool. So good job. Order matters, reduce, okay? And be ready for these, I call it noise. I don't know how you guys think about it, but you know, there's lots of tempting numbers scattered all around, and you have to really zero in on the question and just select the information you need. Okay. Next one. Hopefully I got the answers right here. This was actually my high school mascot. Can't remember any of our basketball season records, which is probably fine. All right, so last season the Bulldog basketball team won only 8 of its 22 games. They lost the rest. What is the ratio of total games played to games lost? Oh my God.
11 to 4.
11 to 4. Good. How'd you get 11 to 4?
4 can fit into both.
You can divide a 2 out of both?
Yeah. Well, my original answer was 411, but then I realized that like you can divide them both by 4 and get a better ratio than 411.
Oh, okay. Yeah, and remember order matters, so total games.
Right. So 411 and 711 should have been crossed out.
Yeah. Yep, exactly. And like I said, you don't have to do that step, but you know, that's some extra kind of logic that even if the numbers are getting a little overwhelming, you can at least say, okay, which is my bigger side? So total games is 22. How do I figure out how many games they lost? Good, right? We subtract wins from total games, and so games lost is 14. And then, yes, we can divide the 2 out of both of those, right?
Yeah.
So the answer is 11 to 7. Sorry about that, Anthony. I got a little excited. I was like, the 11's right. But so for every 11 games they played, they lost 7, which means they're not a very good team. But
It's a tough ratio.
yeah. So we would reduce by dividing a 2 out of the top and the bottom, or out of the 2 sides of our ratio, since I didn't make the fraction. And so of course, I think we talked about this on Tuesday. I believe Ryan bring it up, but you know, if your numbers are even, you can always at least reduce one time. But then usually when you get to odd numbers, that's when it's a little funky, unless it's like a 3 or a 5. So, good. So that's 11 to 7 for number 3. I think I had that one correct. So it looks like, yeah, you guys did well on that one, number 3. And then, yeah, it looks like most of you got number 4 correct too. So very nice. Over half of us got that one. Good job. All right, last question. So the company provided 3 buses to transport their 114 employees. How many employees were on each bus? 30. 38?
38.
Good. How do we get 38? Yeah, so you can just straight up divide, but hopefully, see how you all did on that one, but we're hopefully gonna kind of start again where we left off on Tuesday morning. Sorry, guys, rain, but we could set up a proportion, right? Because we know that there's 3 buses with 14 employees, or sorry, 114 employees. And so if this is my ratio of employees to buses, right, then if I have 1 bus, right, how many employees do I have? But it really does just come out to being a nice little division problem for this one, since we're only doing each bus, which once again is kind of like that unit rate, right, per pound, you know. So if you thought about capacity. Yes, Robert, what was that?
37.
Pardon, Ryan?
I got 37.
You got 37?
Yeah.
114 divided by 3 is 37?
Oh. Like I guessed.
That's okay. Let's see. Nope, the answer is 38. Maybe someone didn't catch the bus on your problem. All right. Any other questions or concerns about our warm-up problems? I wanted them to hopefully be a little bit faster, and hopefully you guys are feeling good. I think you guys did a really nice job on that. So let's see, for the last question, good. Most people got 38. Yeah, it looks like actually can't have roughly 37 people. I guess you could.
Roughly 37.
I like it. But good. All right.
So 38 to 1 would still be wrong.
I mean, it's not answering the question. That's the ratio of employees to buses. But the question is just asking how many employees were on each bus, so you wouldn't need to report it as a ratio.
Okay.
They just want to know, but I guess kind of the capacity of each bus, you could say. Right? It's like when we're doing those unit prices, like how many gallons per mile, how many, you know, dollars per
It's
pound.
just asking for that specific number for that.
So yeah, you wouldn't need to answer as a ratio unless it's specifically saying like what was the ratio of employees to buses. And so here, just kind of pragmatically, right, wouldn't make sense to really want, you don't really need it expressed as a ratio, hopefully at that point, since it is kind of like a unit in a way. All right, any other questions or comments about our warm-up problems? So awesome job, guys. I'll try to make things really hard on Tuesday morning for us so that you don't get a huge ego about things. All right, let's go ahead and hop back into our lesson then. So, hopefully everyone brought their lesson, their workbook with them. Let's see. And then let me grab it from Canvas for you guys. All right. So we got through most of the ratio like ideas and lessons on this page. If you have more questions, definitely let me know. And of course, if you feel like you need practice, there's lots and lots and lots of practice. But today I think we're going to start on page 12. So like I said, if you need more practice with ratios, you know, just kind of a drill, there's a lot of good practice here between pages 9 and 11. Okay, but here's where we left off on page 12 on Tuesday. And so now we're taking our understanding and concept of ratio, and we're going to build from there. And now we're going to look at this idea of proportion. Okay. So just to remind ourselves, a proportion is made up of two equal ratios. So usually we have the most simplified version is going to be one of our ratios in our proportion. And then we're probably going to want to expand it some way. Okay. It doesn't have to be that way, but it's it's just something you might see. Okay. So two equal ratios make a proportion. Okay. Just like if we were going to make equivalent fractions. Okay. Sorry, Naomi. Yeah, things got a little disjointed when we had Monday off, and then things are gonna get a little jumbled around.
Next week, right, or on the 9th, or 9th through the,
Yeah, the 11th and 10th.
yeah, we don't
Yeah.
have any
Yeah.
classes.
Yeah. Next Wednesday and Thursday. So, yeah, hopefully, do you have any questions? Do you feel lost? Like I could, do a little more review, or if you're able to kind of review those pages on your own, but we didn't like go through all of those problems or anything in class. Anyway, talking to Naomi on duty, so. All right. So just try to hang in there as best you can, but if you're feeling really lost, oh, okay. Okay. Yep. Nope. You're not. Like I said, we're kind of skipping it in this live class setting, but I strongly, strongly, strongly encourage everyone to do those practice pages that we don't do. Just to get, like I said, for some people, kind of drilling with those problems is, a helpful way for them to kind of get down what they're doing. So, good morning, Ryan. You look very cozy. All right. So we're working with proportions. So now we have two equal ratios. And so the way to confirm if something is a in proportion, right? If the two fractions are equivalent, if the two ratios are in proportion to one another is how we would say that. You look at the cross products, right? You look on the diagonal between the two ratios, and if 3 times 8 is equal to 6 times 4, then yes, the ratios are equal and you have a proportion, right? Basically, you're doubling 3/4, right? So then if you look here though, if we had 1/3 is a ratio of 1 to 3 in proportion to a ratio of 2 to 5, No. Why? Because 3 times 2 is 6 and 5 times 1 is 5. They are not equal, so they are not in proportion. Okay?
So for them to be proportionate, they both have to equal the same number on both sides.
The cross products have to be equal. So that's going to be kind of our check. If we think we've created the correct proportion and we want to confirm, then we would look at our diagonals and say, okay, do the cross products equal? Then yes, we have a proportion. Yep. And so oftentimes the way proportion problems are going to look for us is usually we're going to have a missing value among the 4 numbers in our proportion. And so there's math that we can do to solve that. If we only have 2 of the 4 pieces of information, we're not going to be able to create a proportion. But it generally, so if you're kind of reading a problem and it's like, well, they gave me 2 related pieces of information and 1 piece of information with kind of the blank. Okay, so you'll always know 3 of the 4 values, and then you can use some algebra to solve for that missing value. And so it's kind of similar to our check once we've created the proportion. So we look at it, we look at the cross products again, but we just care about the 2 numbers. The part with the unknown or the variable here, okay, is what we're trying to find that value. So I take multiply the cross products of the actual numbers. So 12 times 3, okay, which is 36. And then I divide by the other number. So 36 divided by 2 is 18. And so I know that the missing value in this proportion is 18. And so they kind of break it out a little bit more algebraically in this example. If the algebra feels a little, funky, really all you're doing is cross multiplying and dividing. So find that diagonal where you have 2 numbers, multiply them, take that outcome and divide it by the remaining number, and that tells you what's missing here. And so when we get into some of these proportions, calculators can be really helpful and an efficient way to cross multiply and divide. And so once again here, right, we look for our cross product. So 1 times 30 is 30, 30 divided by 6 is 5. So I know that 5 is the value of G that I need to insert to make this a true proportion, okay? But sometimes it's just as easy as kind of doing this idea of, okay, what did I do to my 6 to get 1? I divided by 6. So I do the same thing on the bottom.
So wait, so you do 6 divided by 30. Because it's one times 30 essentially, and then you do 6 divided by 30.
I mean, so it's kind of 2 ways of thinking of how to solve these proportions. And so cross multiplying and dividing is always going to be like our go-to method that's always going to work. But if you know how to like reduce fractions as well, you might not have to do that every time. And so you can be a little more efficient, right, by just kind of treating it like equivalent fractions as well. And so I look and I say, okay, what did I do to go from 2 to 12? I multiplied by 6. So if I do the same thing down here, that will also give me my equivalent value, my proportion. So there's a lot of ways of finding that missing value in the proportion. If they're not like easily divisible numbers, like these 2 examples, then I would say cross multiply and divide, use your calculator, because we're getting exact numbers. So this is where we might see like a decimal needed because it's not even. But yeah, so there's just a lot of ways of seeing and doing this. So once again, I could look here and I'm like, okay, right. So what did I do to a 6 to get a 1? I divided by 6. And so once again, if I do the same thing here, it also gives me my same answer, so. Yeah. So there's definitely a lot of ways to think about, conceptualize, and solve these problems. And so just know that cross multiplying and dividing is always going to work, especially if you have funky, like more, complex numbers to deal with. And then if I needed to check, once again, the cross products, right? 30 is 30, 36 is 36. So I can confirm with the cross products that I did find the correct proportion. All right, any other questions or comments? So like I said, there's definitely multiple ways to think about this. So as we go through this, whatever is kind of clicking for you and feeling good, mostly stick with that method. And so just to kind of check here, if we look at number 3, so is 2/3 in proportion to 14/21? Is this a true proportion? Are these two quantities equivalent?
Yes.
Yes, right? We could check with the cross products, but then I could also say, is what I did to go from 2 to 14 the same thing I did to go from 3 to 21? Yes. Multiply by 7, multiply by 7. Okay. But how about this one? Is this one in proportion?
Yes.
Yes.
Good. 200, right?
200.
Yeah. How about this one?
No.
No. And it's pretty easy when you see 7 times 14. It's going to be way bigger than 21. How about this one?
Yes.
Yes. Good.
Oh.
Good. Right? Multiply by 4. So, I mean, it really depends on the numbers. The even and odd stuff kind of came more into play when we were taking our ratios and reducing them to lowest terms, which really is the same as, right, creating these proportions as well. It's just we want that lowest possible proportion. But once again, you just kind of either, right, whip out your calculator and do 7 times 16 and 4 times 28. If you get the same answer, you can confirm, yes, I have a correct proportion. And then, like I said, the second way that I was looking at it is I just kind of say, okay, what did I do to 4 to get to 16? And is that the same mathematical operation I'm doing to go from 7 to 28? And if it's yes, I multiply both by 4, then once again, I've confirmed that I have a proportion there. So hopefully that answered your question, Nailing, but if not, let me know. All right, go ahead and jump down toward the bottom of page 13, and I want everyone to solve A through D. Okay. Go ahead and work on, so find the missing value among those proportions, please. Sorry, hopefully that's not too bright. Ooh. Sounds good, Ryan. Yeah, so it's really just, sometimes it's going to be increased by an even number, sometimes it's going to be increased by an odd number. And so you really just have to kind of look at the relationships between the numbers. And then Robert noticed our, here in the classroom, I don't know if you noticed, but we have our multiplication table. And kind of the more good your brain is with kind of keeping track of the multiples, it can be very helpful. And let me know when you think you have your answers to these questions, but definitely take your time. And once again, if anything, cross multiply and divide if you can't kind of figure out the change. You guys want to put your answers in the chat? Really? Seems pretty straightforward to me. I am not seeing a lot of ambiguity. There should only be one answer for each variable. It is a good word. I agree. Another 2 minutes or so on these ones. Hmm. All right, another minute or so. Everyone got these ones? All right. So for A, what is R equal?
Five,
I was thinking 3. 8A. Did you do the wrong row?
oh, yeah.
Oh.
Eight, bottom,
8A, yeah,
three.
good.
Sorry.
Oh, no, that's perfectly fine. So yes, R equals 3. Oopsie. Good job, Valerie. Does everyone feel okay about A? If you need me to work it, I can. And so remember, we can always, if we need to figure out the value of R, we can always cross multiply and divide. So 60 times 5, right, is 300. And then divide. 300 divided by 100 is 3. So I know that that missing value then goes into the slot with our.
So we're just finding the missing value.
Mhm. Yeah. And as we get into the word problems, you'll kind of see that if you set up the proportion and solve for the missing value, that's usually the answer of the word problem. All right, how about B? What is S equal in 8B? 21, good. Okay, so once again, I could do 3 times 49, not necessarily in my head.
147.
Okay, thank you. And then 147 divided by 7 should be 21. That sounds good. And so once again, right, S equals 21. So it goes in the spot of our proportion. And then once again, I could use my cross products, right, to confirm that. Or once again, what did I do to 3 to get to 27? I multiplied by 7. I do the same on the bottom, 7 times 7 is 49. Okay. How about number 8C? S equals 1. 1? Good. Okay. 18 times 5 is 90. 90 divided by 90 is 1. So hopefully you're seeing the pattern, Naily, and hopefully it's not feeling quite so funky, but, all right, and then last one, 8D, X equals what? 50, good. 45 times 10 is 450. 450 divided by 9 is 50. Okay, and so, very nice, Mel. All right, so that's the math part, okay? And like I said, we can use this cross multiplying and dividing anytime we're in doubt, okay? If it's, but sometimes you can just kind of assess it once again, if you can do that, but cross multiplying and dividing is always gonna work. And so if this is kind of new to you, then I would just kind of practice doing that, because that's gonna be hopefully the surest way, okay? Is everyone feeling okay about finding a missing value in a proportion? All right. So,
I have a wild question.
Okay.
Are we ever gonna get to algebra?
Probably not this fall. We did algebra last spring. I was trying to decide who was still gonna be around in the spring. If you guys feel like algebra is what you absolutely need, we can definitely kind of change gears, but, you know, this is, I mean, technically what we were doing up here was like a form of algebra, right? We're solving for an unknown value. But, yeah, let me know.
I didn't know if it's gonna.
I mean, there's definitely lots of algebra. I would say it's the majority of the test. And kind of similar to what we're seeing with, like, you know, multiple approaches, multiple ways of kind of thinking and conceptualizing these things. Algebra can also kind of play into that. And so, hopefully as we get more and more into the lessons, we'll have some algebraic examples and some reasons to use algebra that hopefully will, will help. But if you wanted to, if you feel like you need to study some algebra and want some more help, I could give you independent study to work on. Or you could work with our tutor if you wanted to on that. But yeah, that's why we're not doing it right now, because I know yeah, and like I said, you're probably actually still doing it. You're probably just not thinking about it algebraically. You're coming about it from a different angle, because yeah. Yeah, and really, like, anytime it's like, okay, take what you know to solve what you don't know. It's basically algebra. And if you have enough information to kind of figure out that unknown piece, then you're probably doing algebra. And so technically this would be algebra. And like I said, we just don't want to, sometimes people are scared off by that word. So, and so as we continue to work through these concepts, I think we'll encounter a lot of algebraic concepts and stuff. And a lot of them, you know, like I said, are kind of, you know, universal across the types of problems that you're going to encounter and come across. So, but I can give you some algebra materials to look at. And that offer's open to anyone who wants additional stuff. I like teaching this stuff because, like I said, there is kind of algebra folded into these lessons as well. Sure, Naily. Do you want to come pick it up in a hard copy, or I can email it to you? And so, yeah, sometimes, you know, and I think it's okay. I'll put it with your other materials. I put the, hey Vance, put the math and the language arts materials together at the front desk for you, so, yeah, feel free to come and pick them up. So really fast before we continue on, I did want you guys to just look at this box because, you know, once again, it's always helpful for some people to kind of see the practical applications of what we're doing. And so if you are familiar with like Photoshop or any kind of printing or digital graphic kind of stuff, you might be familiar with the concept of similar figures, which is basically, right, keeping an image in proportion to itself, right? Because if we enlarge the photo out of proportion, what happens to the image? Have you ever like played with like an image on like in like Paint or Photoshop? If I paste like a picture and try to make it bigger, but it's like out of proportion to how it was originally shaped.
Or zoom in.
Or zoom in, or copy crookedly, but right, if I enlarge my photo but don't keep it in proportion, right, then the image gets distorted in various ways, right? It looks like stretched out weird, or it gets like too compressed in areas, and so once again, that's a place where we see proportions are very important. And so it's easy to take an image, and sometimes it will only let you, right, kind of like enlarge it in proportion to itself. Some programs are like that. But anyway, just a way of thinking about it. So if you see a question that uses this term similar figures, which I know I've seen it on progress tests. I can't remember if I've seen a GED question. But basically, it's just asking for proportions, right? And so we're saying, you know, if this is kind of my original and I want to enlarge it into twice its size, then I need to enlarge it in proportion so that the lengths are in proportion and the widths are in proportion. Okay. So, not super important. That's why it's just a little box here, but think about that. All right. So like I said, as we begin to apply our knowledge of proportions, this is generally how we're going to be tested and asked about it. And so when you encounter a proportion problem, usually it's a matter of labeling the information. Here, they're actually turning it into a table, which is a really good strategy, which is something, right, we were doing when we were doing algebra in the spring. But like I said, generally with these proportion problems, excuse me, you have 3 known pieces of information and then 1 unknown piece of information, okay? And so we should have 3 numbers and 2 units, okay? And of course, what I mean by units is how this table is labeled. So I should have 2 numbers associated with 1 of my units. And, right, I have, okay? And so the proportion, right, is my circuit boards per hour, right? And so I would set it up by saying, okay, right, if I can make 48 in 8 hours, how many can I make in 6 hours? So then I set it up like this proportion, right? 48 circuit boards is to 8 hours at how many circuit boards are in 6 hours, okay? And hopefully you see how this should look like our proportion that we've already seen, right? And then we can just do our math. Or peek at the answer. Oh, I don't have the answer available. Just a sec.
Are you talking about the answer for this?
Yeah, I just
It's
can't
36.
scroll down or it's gonna, 36?
Yeah, 36.
Oh, yes,
A,
yes, thank you,
48 times A
yes,
divided by A, or
it's 36,
yeah.
good. So you don't necessarily need to make a table every time, but I really always want to make sure that I'm organizing the information in my question so that I can create the correct proportion. And so what you can see here is, right, that we have our units are going right in this kind of horizontal way, or like as rows. And so you have to make sure that your units are aligned. It doesn't matter if they're on the top or the bottom, because remember, all we need to figure out is our n. We don't need to actually know the whole proportion or anything. And so our units need to be excuse me, horizontal to each other. And then, right, our verticals are our ratios. So we should always know one whole ratio for sure. And then we should have 1/2 of the other ratio that should have matching units to one of the things in the whole ratio that we're given. Hopefully that makes sense. Uh-oh, the screen went blank. Serial?
No,
Did you just close your eyes?
no, I'm kidding.
Oh, and you made me erase all my stuff, dude. All right. So of course you do have to know that of course a proportion won't save you in all situations, but I think everyone feels good about this. We kind of saw that in our last question. So here, if we have this question of the 48 circuit boards that Mary Lou completed on her shift, 46 were ready to be shipped. How many boards were not ready for shipping? Well, hopefully you guys would agree we can't create a proportion to help us with this problem because number one, we only have 2 numbers. We don't have 3 numbers. And we have pretty much the same, well, we have 2 different units, right? We don't have matching units. And so of course, this problem is easy. All we have to do is subtract and know that 2 of the 48 are not ready to be shipped. Okay? So go ahead and on page 15, go ahead and do exercise A. Okay? So put in the correct numbers in the table below and then use the tables to help you write a proportion and solve for the unknown. So there should be 3 numbers from the problem that you should be able to insert into the table and then use your cross multiplying and dividing to figure out whatever's the empty square among the 4. Okay? All right, I will be right back. I wasn't planning on going over that, Mel, but once again, proportions are very similar to functions, right? In that as one part of your proportion changes, the other one does as well. If you need to like dig into that and kind of, rehearse or practice that more, you could, if you have any time outside of class, we could definitely work on it one-on-one. Or if you have any afternoon availability, you could work on it with Kelly, our tutor, but, I can certainly provide you materials to help you kind of focus on that area if you feel like, but once again, it's hopefully feeling similar enough that you could hopefully kind of apply both pieces of information, but. Guys need a few more minutes on these 4 problems, or are we ready to talk about them? So like I said, hopefully kind of you guys are kind of beginning to kind of see the pattern here. And so once again, I always feel like these ones, like if you know what to do, hopefully they're not feeling like super hard.
They make sense.
Good. And it's really just a lot about organizing the information. I'm gonna turn my pencil on.
It's just, you just gotta read it carefully. That's
Yep.
basically all it is.
Yep.
Read it carefully.
Yeah, it really is about, and that's probably most of what they're trying to assess, right? Can you organize and put information together and then, kind of figure that out. So number 1, right? So 320 miles in 8 hours. So what does that look like in 10 hours? How many miles?
400 miles.
400 miles? Does everyone agree? Good. And so cross multiplying and dividing is going to be the best way. That's not even, right? I guess, yeah.
But we're just finding that missing number, or
Mhm,
that missing
mhm,
letters.
Yep. Number two, we've got 2.5. So like I said, you can see decimals in these ratios of proportions. Just use your calculator. And then of course, although this one you might not need to, right? So how many gallons do we need for 12 wells?
Wait,
How many gallons? We need 5. And that one's not too hard because it's like, oh, well, right, we just double. So double. Rubble. Yeah, I can do that for you, Mel, no problem. All right, number 3, we've got 2.54
Over one.
over 1, and then if we say 101.6, how many inches is that?
40.
40? Does everyone agree? Good, and then this one, we have 1 yard, 36 inches. And of course, you could think of 2.5 as 2.5 if that's easier for calculator.
So does it matter?
No,
Look at half over two.
yeah,
it's the same
yeah,
thing.
it's the same value. It's just sometimes, like if you don't have a nice GED calculator, you can type in mixed numbers, just the fraction version is always a good go-to. So let's see, how many inches in 2.5 yards? 90. 72 plus 18. All right. So, good. So that's, yeah, the big takeaway here for these is with these type problems, organize the information, read the question carefully. But once again, if you're like, okay, they've given me 3 numbers, I have 1 missing number, I have 2 sets of units, so probably, all right. I will, yeah. Okay. Good. What time is it? Okay. Let's keep rolling. So you guys are doing well. Like I said, I like to highlight is another good way to kind of do that. So if you need kind of help, once again, deciding, do I need to use a proportion or not? You can look at those ones. No worries, Lance. Glad you could join us for a little while. So once again, I would say the majority of the proportion problems that we're going to deal with are going to be word problems. And the cool thing is that proportions can help with a lot of different things. So if 5 boxes of matches cost $1.25, then 3 boxes would cost 75 cents. And so once again, the most important thing is to keep your units, right, in a row. And then, yeah. And so as you can see, like, as long as your units are either together on the top or the bottom, you're fine, right? It's going to be a problem when you don't have your units in a row. Okay. We're going to put units in a row. All right. So this isn't in proportion because number 1, we're not comparing dollars to dollars and boxes to boxes. And then 5, and then our cost products aren't equal either, right? So that's the only kind of thing to remember here. So if we look at an example, and so this kind of goes back to our unit prices and stuff like that, right? How we were figuring out, right, how much 3 pounds of something would be, or 1 pound or 2 pounds based on, right, some ratio of the unit price. Okay. So at Floyd's Market, 2 pounds of greens cost $1.40. At this rate, how much would 3 pounds cost? So once again, I see pounds. So I have 2 groups of related units, and then, I see, okay. So I know 1 price, and then my missing information is the other price. So set up my ratio. I know that 2 pounds for $1.40. So then I set up my proportion, right? Keeping my units together in a row. and then solve the proportion. And so, 3 times 1.4 is 4.2. 4.2 divided by 2 is 200 or 210, 2.1 or $2.10. Okay, so so proportions are really helpful when you need to either reduce a recipe or increase a recipe. Once again, you want to increase all of your ingredients at the same rate or in proportion to each other. Otherwise, you're probably not going to have a very delicious outcome. Okay. And so once again, it doesn't matter which unit is on top or bottom of your ratio, like it's showing here. We could have put dollars on top and we still would get the right answer. And so it doesn't really matter what order you put your ratio in for this, as long as, right, your units are in a row. Okay. So if it's just a ratio, order absolutely matters. If we have enough information, we're using a ratio to create a proportion to find an unknown value, then we just need to know that we have to organize our proportions so that our units are in a row. Okay. So that's what it says here, right? So once again, as long as you can kind of organize information, you should be good.
Why is it Parker? Yeah.
All right.
Wait, can you go back?
Oh,
a second?
yeah.
Okay, good. You can go back down if you want.
All right, just 1 second. Okay. So just to kind of see how we do here, go ahead and look at 1 and 2. So this is just the setup stage. This isn't the calculating stage. But go ahead and look at number 1.
So are we just setting up the problem or are we solving the problem?
Just the setup, and know that, right, there's at least 2 or 3 setups that would possibly, well, there should be 2 out of these 4 choices that could work. So yeah, just how would you set up this proportion so that you can solve the question? So it looks like we have miles.
What we're gonna answer?
So like I said, these are kind of like multiple choice answers. So if this is our proportion question or problem, there's at least 2 of these proportions that would work for us to set up our problem. So Nayeli says 4. Okay. Is there another one besides 4? 3? Good. Yep, 3 and 4. Right? What's wrong with 1? Well, we have hours over hours. Okay? We can't create a ratio of the same units to same units. And then what's wrong with number 2? Is there anything wrong? Yeah, right. Once again, we don't have our units in a row. Right? We have miles and hours. That doesn't work, right? That's our ratio, not our, shared units to create a proportion. So good job. All right. So definitely, once again, you can look at the remaining problems on page 17 here. And the answers are at the back of the unit. So you're definitely welcome to work on these problems on like 17, 18. I think we're going to have a lot So yeah, if you want to do the practice problems on page 17 and 18, that would be a really, 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 really good idea. Okay. Robert, let me grab the, I got something on the copier, algebra related for you, so don't go away. All right. And then Mel and Naomi, I will have your materials ready for you guys at the front desk to pick up, okay? Yes, yes, I'll leave all of it for you with your name on and post-it note. All right, everyone in here good? Awesome.
Thank you.
Yeah.